now we have another problem. So we know how to use basic types that we call primitive types. So we have the you have the integer int, you have long, float, you have double, you have the character. But now you want to you want to use something more specific, like a human, for example. Okay, so you can say that a human is a number. You can say that a human is a character. You can say that a human is even a pointer. That doesn't make any sense. Neither that a human is a string. In this example, in this situation, we will learn about structures and about how they can help us to represent things that are not that do not exist in our programs by default. So here we have a structure. This structure represents a human. A lot of stuff happen here, so it's very simple. I'll split this way. Okay, so first we have this part. We'll define a structure as human. We'll say that a structure is basically a group of different attributes. These attributes will be put side by side in the memory, and the union will create like another type, something like another type that you can use later. I explain how. So we want to create this structure. So S human, and we'll say okay. So a human has two things. It has an age, and it has a name. Okay, so of course age is an integer, and a name is a character pointer for a string. We'll add type def before, because to make our life easier and call this type not struct as human, but just human. If we don't add that and you want to use that the type without the type def, you will have to say every time struct s human a equal something, and now you just need to do human this way. Okay, so here up and up. Okay, so now how you can create a human, your new type. So we have a simple function that return a human, that will take its age and its name. We create our variable of type human, of course, and we will return it here. Now we will assign the value to each field. So for the age, we will assign the value of the argument age, and name we will assign the argument name this way. It doesn't have to be the same name actually, that's just a convention, so that age right here is the same as age right here. If you write something like banana here, okay, what's it also works, but yeah, it's the important that when you reference h point age, it does reference to this field right here. If you don't add this, it will refer to that parameter. And if you don't have a parameter named age, you won't refer to anything. That will be a problem, and your code will not compile. So this part is very important, and of course you will return it. So here we just have to call our function, and so we create a new human named Toto, because I have a lot of imagination when it comes to names. and it will be equal to create human to the return value of the function create human with an age of 21 and an age of Toto, and then we will only we will print our human. So with still my referencing the different values with the name of our type, points, very important, the name of our field. So here name, age, right? If I run that, we have okay, name equal Toto, age equal 21. So everything works fine. And so that's the basics of how you can represent a human. Notice that that's not a pointer. That's very important that that's not a pointer. Because for example, if you create a function that say okay, yeah, add birthday. Okay, so it's the birthday of a human, age, and you, so we give you while more. So we say age plus. Okay. So now we say it's the birthday of Toto. He's very happy and everything. And oh, sorry. This way is better. And here we print it again. So you can now you can expect two things. Either the age will be 21 or it will be 22. And if you follow me, if you have followed the class about pointers, you already know what's gonna happen. Sorry. The line breaks here. Okay, so now we have 21 and 21. Because the age of Toto hasn't been changed here. Why? Because human is not a pointer. So what's happening here is that when we call our function, it will make a copy of Toto, of our file, and so it won't be the same place in the memory. It's kind of like we have twice the value in our memory. It's a bit more complicated, but in the idea it's that, and it's behave like that. So when we when we increment the value of age, it will change this value only in the scope of that function, not in the scope of the main function. So the value will stay the same. Okay, but that's not what we want, of course. We want that the function birthday will increment our human. We have two possibilities. Either here we return a human, we say return human. So return, sorry. And so every time we will have a new birthday, we will create a new human that will be a copy of the previous one, and increment its age like this, with one more on its age. That's one way to do that. But there is another way with pointers, of course. And that's the one we can see that. So we will go back to a void function. Here it's a pointer, so we'll add a little star here. And here, if I want to do that, there will be an issue. Okay, so why does this work? Because C is not nice for that thing. H here, it's not a human, it's a pointer on a human. So when you say h.age, it doesn't understand anything because it's a pointer, it's not a structure. It's a pointer on a structure, but not a structure. So what we need to do, it's not a point here, it's an arrow, like this. So it's like the minus sign and the right chevron. And here, if we do that, of course here, it's a pointer now. That. Yeah. So now our edge has been incremented by 1. So now Toto is 22 and he's very happy and everything. So these are the basic thing about how to use structures with pointers. So that, as you saw, that's not an art subject. Structures are very easy and very useful for many cases. For example, when you use a very simple structure that you can see many times is, for example, type def. So we have a structure called, we'll call it array. Sorry. I add s underscore before. That's only my way to do that. You don't have to do that. You can use any name you want here. That's not important. And if you, for example, you will have here you have s inter, but it's better, I think. Okay. And elements and size. And if you use that, you can say that int pointer is a pointer to a table in the memory, where you will have all of your elements, of course, like you used to use tables. And size is represents the size of that table. As you know, it's hard to know the size of a table in C, and it is better to know it at all time. So a typo. And so the thing that you can do is use a structure like this, so that every time you use an int array, you always have the information of the elements and the size of the array. Of course, I always use 2 fields, but you can have as many as you want. You can even have none. I think that's work. Not sure. Let's set that. Does that work? Yeah, that's work. You can have a structure with no fields. I don't know why you need that, but that's possible. That's a possibility. Okay, so as I say, that can be something to represent that. In the project, you will have a hero to create. In that hero, we have, for example, I create as hero. That hero will have name. It have, for example, a power. It will have it will have life points. Lives, yeah, not sure. Well, life points, yeah, maybe, I don't know. Okay, and this is how you will manipulate, you will control your character using structures like this. And yeah, that's not very hard. It's very simple. Everything is always very simple, of course. So you only need to add this and okay. At all time when you have your character, you know that you have access to its name, to its power, to its last points, to its magic power, or to in mana, or I don't know. You'll have access at everything at all time, and that's make it very easy to manipulate. Little story in my personal experience. When I first learned the C programming language, I didn't know about pointers and I didn't know about structures. And they asked me to do a video game like Mario. It was a simple game. And it was very, 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 very difficult to do because I didn't have pointers and I didn't, except for strings, and I didn't have structures. I didn't know how they work. I didn't even know that they exist. My mistakes. So, and that was very hard and very difficult experience. And when the project was over, I returned to the code with more knowledge about pointers and structures, and I erased everything because everything was so difficult, and everything could be a lot more simpler with just structures and pointers. So that's why these are very important topic in C. And something that's also very important before I thought, when you use structures, you are not using objects. Often in the forums on Stack Overflow and everything, they talk about if you if you already know object-oriented programming language like C++, C#, Java, Python, JavaScript or everything, it has something they call a class. A class is the definition of an object. A structure is not a class. These are totally different things. The objects in C++ behave a bit like structures in C, but they're more complex, far more complex than only structures. And for example, in Java, in Python, and everything, and every other object-oriented programming language, in every object-oriented programming language, objects behave in a very different way. As I said before, often objects are pointers in somewhere in the memory, but they are not pointer to structure. They're often pointer to a map, for example, for the fields, to a list that contain pointers to each field, something like that. That depends on the language, of course, the implementation, and for how you use that. C is not an object-oriented programming language. It's that we call a procedural language or structured-oriented language. And a structure is a block in the memory. If you don't use pointers, there are no pointers involved in the structure. And that's a very important thing. If you use, for example, as you saw here when you create a human with that function, you're not using any pointer. You're just creating something as structure, and you don't need to say in the memory you will just have somewhere in the memory an integer and a pointer to a character array, to a character string, and that's it. Okay, so I hope these two topics you and I hope you understand these two topics well. Don't hesitate if you have any questions to post them in the comments. I will be happy to answer you. As I said, these are not difficult topics, but you might need to go back to the exercise, to the class when doing the exercise or when doing the projects. That's okay. That's completely normal. As I say, it's a click. It's pointers are like, okay, it's hard, I don't understand. Okay, so now I need an int or a pointer on an int, or a pointer on pointer or an int. That's something that's happened. Okay, you don't need and then one day it's okay, that's obvious. for this I need a pointer and an integer. For that I need an integer simply, and that's it. And you don't need anything else. And when you will have that click, everything will be even easier. Okay, so that's it for this class. I hope it was nice to you. So as I said, don't hesitate to ask you questions, and see you later.